Okay, welcome to another episode of Chemistry with Chemistry. Do you have chemistry with chemistry? Let's find out. In this episode, this is our first lesson for 2025. Gabriel is so excited. You might want to use the tissue, Gabriel. Yeah. There's tissue here, dude.
Oh,
Yeah. He's so excited he's having a running nose right now. Are you sick or something? Okay. And Samuel's wrong lesson, Samuel.
it's personal accounting. I think of personal financial expenses issue. Yeah, yeah.
All right, let's get going. What's the answer for the first question?
Okay. That is wrong. Yeah. I pick C.
Gas strange. Okay. You pick A, which is the measuring cylinder. So both stopwatch, but you pick the measuring cylinder, you pick the gas range. Why would you use a measuring cylinder?
Yes.
What will you measure with a measuring cylinder? Okay. What gas is given off here? Gabriel, what do you think? Is it correct? You have a carbonate and acid. So what gas will it be?
Actually, I don't even know what's written there. Oh, yeah, okay.
All right. So you got to read the question. Remember, before we went for the break, I said you need to revise, read questions properly. It starts today. It starts yesterday, actually.
None of us did it yesterday.
But if you didn't do anything, then it starts today. So, how would you use a measuring cylinder to measure gas? You can't. All right, so you got to use a gas range. Now, I would challenge you guys to draw a gas range in the diagram. Yeah, because you know why? There's like a 2-mark question there.
That is a
Yeah, there you go. So go and draw a gas range.
That's your problem. Oh, seriously, you must do it. Also, remember on pencil, okay? I'm now a dedicated student and I have a pencil.
It's good for you. Should have done that years ago, but okay.
You don't draw what? You draw, yes, or
Gas range. Once you're done drawing the gas range, draw a stopwatch. What's the answer for 22? Gabriel does not need to do this.
Oh,
All right, let's see if Samuel is
Pure gas.
correct. Pure gas.
okay, not pure gas, like it's like PBT, some semi-calcium.
Is white PPT soluble in excess? The keyword is soluble.
Everything wouldn't be solid.
So it cannot be soluble. So it'll be zinc. Zinc is one of the cation that is soluble in excess for sodium hydroxide and white precipitate. Okay, this can be found in your QA table, of which we have gone through in the past. All right, this question is under QA. What about the barium nitrate test? Acidified barium nitrate, white precipitate. Test for what? What does a white precipitate mean? Can you tell me the chemical formula of the white precipitate? The white precipitate is barium what?
Sulfate.
It is correct, barium sulfate. So if it's a test for sulfate, then it should be yes. Yes. Good that you know. See? First day of lesson. There we go. And next we have question 23. One on B. Challenge you guys.
It is a mixture. It is a mixture. And two B is everything same size.
So one on B. Same size meaning what?
It's the same.
So is it B? Okay. D is correct. Different size as what Samuel mentioned. B is incorrect because it's the same element. Same size meaning same elements. Okay. Moving forward. What's the answer for 24? A. Let's see. So I challenge you guys again. Why not C? Okay, that is correct. So A is correct. 25? Methane is one of it. That's possible. Methane is CH4. And that sharing electrons represents covalent bonding. So A is possible. Let's take a look at, wait, Gabriel, what's your answer? Let's take a look at B. We have a metal and a non-metal. Would there be sharing of electrons? Metals, what? What electrons? Complete the blank. Metals, non-metals, blank electrons. Nope. Metals lose electrons, non-metals gain electrons. So the combination of these will give you ionic bonds, which is not sharing. So B is not correct. You need a combination of non-metals and non-metals for covalent bonding. Covalent bonding is when you have a non-metal bonding with a non-metal, which makes A possible. What about C then? Samuel, why not C?
Yes.
Noble gas. So what does noble gas do?
Nothing.
Covalent shells, electronically stable. Okay. So there's no sharing or giving of electrons or taking of electrons. So C is not correct. Sodium and iodine. What kind of bonding is that? Ionic bonds. You want to look for covalent bonds. So A is the answer. Samuel wins this round. $26. Yeah, both incorrect.
Huh? Yeah.
Oh, if it's not C, then it must be B, huh?
Yeah.
B is correct.
Ah,
The difference is ions. In molten calcium chloride, it's ions that are free to move. Electrons are not free to move. Electrons are free to move, only exist in what? Metals, yeah. We call them delocalized electrons. So that is not correct. Okay? Samuel, what do you think?
what is it?
Yeah, why do you think you got it incorrect?
I think I saw the ions and the electrons. I was thinking free floating electrons.
Okay. Which only applies for metals. All right, what's next? 27? What is the answer?
C
D, Q, R. That
is correct.
is correct. Gabriel? D or B? Okay. Do you need me to explain? Okay. Oh, 28. Stoichiometry.
One says none.
What's the very first step for stoichiometry? For chemical calculations, step 1. Find number of what?
What about moles?
Did you find number of moles?
Yeah.
When you don't have, you can ask for it. In any case, you do not need the periodic table for this one. Because you are given volume and concentration. What can you do with that? What's the formula for moles involving volume and concentration?
Let me pull up.
I don't expect Gabriel to know that because that's not in the N-level syllabus, but Samuel should know. Whoa, Gabriel's celebrating, man.
Yeah. Go back to G2.
You should be happy that you're doing G3.
Concentration times volume.
Waited a long time for this.
Concentration times volume.
Yeah, so what should it be? 200 times 1, is that correct?
No. Um, 200 times 1, yeah. That's what I said. What's 200?
That is incorrect. It's 200 divided by 1,000 times 1.
Also 0.2.
Because you have to convert the cm cube to dm cube, which is done by dividing by 1,000. So 0.2. So you have 0.2 moles here. What's the next step? Mole ratio. What are you finding? Hydrogen. What are you given? Hydrochloric acid. So you put the HCl and the H2. What is the mole ratio? You find the mole ratio by looking for the number next to the chemical formula. So if you are given 0.2 moles of what?
of HCl.
If you are given 0.2 moles of HCl, how many moles of hydrogen will be produced?
0.1.
0.1. So if 0.1 moles of hydrogen is produced, you can then calculate the answer.
0.1.
You're supposed to find maximum volume of hydrogen gas. There's a formula to find volume of a gas.
N equals volume over 24 decimal dm3.
That is correct. So you have N, which is how much? Equal to volume over 24 dm cube. So the volume of hydrogen gas is then 2.4 dm cube. And therefore C is the answer. And that is how it's done. A 3-step. A lot of these moles, MCQs, it's like a 3-step. A lot of the mole questions is a 3-step as well. You follow the 3-step, you'll be fine.
So let's get the number of moles, get the mole ratio and calculate.
Yep, it's always the same. If you notice all my presentation in the past, always the same, 3-step. There will be extra step sometimes, which is writing down the chemical equations. But that's for the pure chem part.
Oh, no, what's the pure chem?
Most of the time, as a combined science student or N-level student, you'll simply be given the equation instead.
MCQ or just like a good general?
The exam in general. You may be asked to balance equations, but that's easy. Okay, next, 29.
29. Well, see, because I have no idea what I was doing.
Try it again. It's a 3-step thing. Step 1, find the number of moles. Step 2, compare mole ratio. Go and try it. All right. What's the first step? Find number of moles, which is 30 times 0.5. You can leave it as this. It's fine if you want. What's the second step? 1:1 mole ratio. So if 30 times 0.5 is the number of moles for the sodium hydroxide, then it would be exactly equal to number of moles for dilute nitric acid, which is 25 times X. Leave it as X. Then just solve for X. Okay? And that'll give you what?
Yeah,
Okay. I assume your calculating power is correct.
Yeah.
All right. Moving on. 30. What's the answer? In order of the nucleon number?
I have the
Why don't you take a look at the nucleon number now and see if it's in order?
hold on a second. It's not A and B for sure. Bottom B. Bottom of B. Oh, I see.
They are not arranged in order of nucleon number. They are arranged in order of what? Proton number. D or B? It's definitely delta. It is not delta. It's always the same what? Same group, same valence electrons, same chemical properties. Same number of valence electrons. Therefore, they should have same chemical properties. So C is answer. Similar chemical properties. What about B? Group 7, reactivity increases down the group. Is that correct?
Of course, no.
Should decrease. What's the most reactive element in group 7? Or group 17? Fluorine. Same period has similar chemical properties, physical properties. What makes you guys think that's a correct answer? Let's take a look at period 2. We have lithium. Okay. Right. What's the state of lithium in room temperature? Solid, liquid, or gas? Solid. What's the state of fluorine? Room temperature.
Yes.
So they have similar physical properties.
Yeah. Yeah, what makes also like, yeah, like, you know, they all know the same thing.
My God. So think about that as you're doing the question. You need to spend time thinking about it. Everything you're doing is being logical. This is a science class, dude. It's all about the logic. 31. R has less electrons shells than T. Group 7, 17. Okay. R has less electron shells than T. You're asking for not correct, man.
Wait, what? No, correct one. Oh, shit. I didn't know. I had to read it. I don't correct.
Okay, in group 17, we have fluorine, chlorine, bromine, iodine, astatine. Now, tell me
Wait, so this. Wait, oh, I got it.
Tell me what happens to the melting point as it goes down.
Uh, decreases.
No, the melting point increases as it goes down. So R will be higher at the top. T will be lower.
Oh, I read it wrong.
So R would definitely have lesser electron shells than T. So A is correct.
Oh. Yeah, good, right.
A is correct, therefore it's not the correct answer.
Oh, okay.
A is true. A is true.
I saw you correctly. I don't read the question. Yeah. I'm gonna read wrong. Wait, then is it C? Wait.
Tell me why C is correct then. Tell me why C is not correct, therefore making it correct.
Wait, okay. R has more electrons than T, impossible. Because
Why?
R in the case of the in period 17, in group 17, sorry, if you have more electrons, you're less reactive.
R is higher than T, so can R have more electrons than T? R
Like
is
that's like saying fluorine has more electrons than astatine. Yeah.
yeah, so C is therefore not true. And therefore it is the correct answer.
Oh, I see. Yeah.
Okay, R is higher than T. R has lesser electrons than T. All right. Moving forward. You see, so nice. They give you this
Yeah, so nice.
most reactive, least reactive. If you're in pure chem, you have to memorize everything.
Okay, only people feel can shut it together. You and I clearly don't feel guilty. Did you feel any?
Okay, what's the answer for 32?
I put B, sorry.
Gabriel?
Mm.
Just because you put B, you put B, yeah?
Mm.
Let's see if B is correct.
Oh,
Aluminium displacing iron. That's possible. B is correct. You need to find a more reactive.
Delta a bit Bravo. Bravo.
Yeah.
Yeah, okay.
Displacing the less reactive one.
Oh, my God.
Okay. 33.
I don't know, but I think I put A. I put A also actually doesn't really make sense. I know it's not T for sure. Yeah, definitely. It's not is definitely malleable.
Okay, group 1 metal is a metal and all metals are malleable. So it's A, B, or D.
Wait, my
Group.
E.
All metals are malleable. So it's A, B, or D. C is not. Can metals conduct electricity?
Yeah. Yeah.
So
Oh, so it's A. Wait, no.
you only left with A lah.
Oh, yeah, right.
Okay. Now, group 1 metals have low melting point, boiling point. You got to take note of that. They have low in the sense that they should be higher as a metal, but they're not. That's why they're low.
It's supposed to be higher, but just higher.
Yeah, if you compare with other metals, they have way higher melting points than the group 1 metals. Cesium is the group 1 metal. Yeah. So if you compare with like zinc, iron, aluminium, they have way lower melting point. All right. 34, what's your answer? I got a D, I got a B. Okay, let's see who is correct.
Yeah, probably wrong. Yeah, probably wrong.
Okay, it forms a yellow color in distilled water. Distilled water is what pH? 7 is correct. It forms a yellow color in acidic solution.
That's 7.
So it's below 7, but changes to red when sodium hydroxide is added to it. So what pH is that? So it's more than 7. Okay, so we need to take note of that. So which means that you only get 2 colors. All right. 7 is here. Anything below is yellow. Anything above is then red. So you need to draw it out, map it out first. Okay, lime water. Above 7 or below 7? Lime water is what? What's the chemical name of lime water, Gabriel? Is calcium what? Calcium hydroxide. You gotta remember that. What's the chemical name of limestone?
Doesn't come in.
Calcium carbonate. So you gotta know all this. Vinegar, what's the pH level? Less than 7. Okay. All right, let's see. Lime water, more than 7 is red. So B is correct. D is therefore wrong. Let's see. Yes, vinegar is less than 7, and therefore it must be yellow. Okay? Samuel is gone now. What's he doing, man? Samuel! 35. Unburned hydrocarbons do not produce acid rain,
Oh, okay.
and they're not produced from volcanic eruptions. C is correct. Nitrogen oxides produce acid rain. They dissolve in rain to form nitric acid. And they can be produced from lightning. So what happens is that you got nitrogen molecules in the air, triple bond, very strong. One day, lightning strikes happen, passes through the triple bonds. Then you get nitrogen atoms very reactive, willing to combine with oxygen to form oxides of nitrogen.
Nitrogen oxide.
It could be nitrogen monoxide, it could be nitrogen dioxide. That's why they call it oxides of nitrogen.
Both of which are pretty bad, right?
No, NO is fine. NO is neutral actually, but NO can become NO2 quite fast. Yeah. NO2 will then be the one that forms the acid rain when it dissolves in rainwater.
So NO2 plus H2O gives you acid rain.
NO2 plus O2 plus H2O.
That's all.
Yeah. And that gives you HNO3. All right?
Isn't HNO3 nitric acid?
Exactly, acid rain.
Oh.
You just said it for yourself. Nitric, what? What's that again, Samuel?
Nitric acid.
Acid. And what do we have for acid rain? Acid. There you go. Oh yeah, we are done. You know what this means? A break right now. Come back in 10 minutes time.